Hi y'all, in this video we're going to be talking about the electron configuration and noble gas notations of elements. But before we get started with that, we have to look at a principle that will help this to be understood a little bit better, and that is the off-bow principle. This is said where the electrons must fill the lowest available energy sublevel before filling up the higher ones. In this case, we start here at the top, 1s, 2s, 2p, 3s, 3p, 4s, 4d, 4p, and it goes up to here, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, and ending with 7p. Now I've made a little periodic table over here to kind of make it understandable a little bit better. When it has one dot, that means it's the one energy level. When it has two dots, it's the second energy level. When it has three, it's the three energy level. Four energy level. Five, the fifth energy level. Six, the sixth energy level. And seventh, the seventh energy level. But as it goes up, I also labeled the S sublevel, P sublevel, D sublevel, and the F sublevel. So we start here at 1s. These two fill because S can only fill 2 electrons. Then we go on. Here we've got another 2. And then we continue on all the way over to the P energy level. The P energy level can only hold up to 6 electrons. We continue to go down. Here's the third energy level. And this one, it's another s orbital, can only hold 2 electrons. We continue to the other side to the p. This is the third energy level, continued. That's why we go in this order so far. We're here. We continue going down. We're now at the fourth energy level, 4s. And then we continue, but here is where it starts the D energy level. And this D energy level can hold 10 electrons. We continue to go through the P, which can hold 6, but here's the fourth, 4P. We continue going down. We got 5s, and then continue with these, another D orbital. And then we go to here, and we go to 6s. But keep in mind, right here on the periodic table, these two is where it drops down. Well, in between those two. It's where it drops down to the F orbital. F orbital can hold up to 14 electrons. Finishes through here and then continues here in the D orbital, like it says here, 4F to 5D. There's the fifth. Then we keep going to the sixth P orbital. Keep going down, we've got the seventh, 7s, which is here in our line. Continue, but wait, before we get to that D, we gotta go to the F. Here's 5F, that can hold 14 electrons. And there's 5F. We get through that, we go back up to the 6D and end off at the 7P. This is the off-bell principle. We'll need to understand this to work on these electron configurations. So, let's do an example. We'll do a couple. So lithium's electron configuration, try and say that 10 times fast. Its configuration, the first thing we're going to have to do is find it on the periodic table. Luckily enough, I have a periodic table. Lithium, it has 3 electrons. Since it has 3 electrons, we're going to have to fill those orbitals up with the 3 electrons. I'm going to remind myself how many electrons lithium has by writing a little 3 there. Step 1s can hold up to 2 electrons. So we're going to write 1s, and that is the first one on our line here. 1s, 2, we need to get to 3. We currently have 2 electrons. So now we're going to have to fill up that next available spot, 2s. And yes, the s orbital can hold 2, but lithium only has 3 electrons. So it's going to be 1s2, 2s1. Now, the noble gas notation for lithium, we're going to go back on our periodic table, and the previous noble gas is what we're going to use. This column here, column 18, are known as the noble gases. These are what we're going to refer to when we talk about noble gas notation. So lithium is here, all the way on this side. It has 3 electrons. We're going to have to go back to find the previous noble gas. In this case, it's helium. So we're going to use that. Our noble gas notation, we're going to use brackets, He, and then helium is the same as 1s2. These are the same. They could be interflipped. That's why the electron configuration and noble gas notations are so similar. The noble gas notation also gets referred to as the shorthand. So then all we have to do now is bring down the excess electrons from the noble gas. In this case, it's just 2s1. Let's do the next one. B. B is boron. Boron has 5 electrons. I'm going to remind myself in the corner here how many electrons boron has. It has 5. Since boron has 5, we're going to have to get to boron. We're going to start in the very middle of our electron and go outward. The first orbital is 1s, followed by 2s and 2p. So we're going to go 1s, 2, because that's the max it can hold, 2s, 2, again, the max it can hold. We're up to 4, but we need to get to 5. So this next one is going to be our 2p. 2p1. That is our electron configuration for boron. We have a total of 5 electrons. Now we're going to have to go back and do our noble gas notation. Noble gas notation, we're going to have to look at our periodic table here. Here is boron, and we're going to have to go backwards. We've got 5, 4, 3, helium. Helium, again, is our noble gas that we're going to use. So we're going to use brackets again, He, and then again, helium is the same as 1s2. We're going to bring this part down, 2s2, 2p1, because that, all of this together, is the electron configuration for boron. Let's do another one. Oxygen. Oxygen on the periodic table is right over here. It has 8 electrons in total. So I'm going to remind myself we've got 8 electrons to fill up. So the first thing we're going to do is we're going to look and notice where our line is. The first one we start at, we're always going to start at, is 1s. We're going to fill that completely up. And then we're going to do the next one, 2s2. We're going to completely fill that one up. And then we've got 4 electrons so far, so we need 4 left. 2p. The p orbital can hold up to 6 electrons, but all we need in this instance is 4, because now we have 4 electrons here and here to make a total of 8 electrons, and that's what we're looking for oxygen. Now for our noble gas notation, we're going to look at the previous noble gas. We start here, and yes, neon is closer, but neon has 10 electrons. We need to find the noble gas that has the least, well, the greatest common noble gas. Oxygen has 8 electrons. We got to go back all the way. Helium has 2. We are going to use helium as our previous noble gas. So we're going to use our brackets again, He, and again, helium is the same as 1s2. Then we're going to just copy down the rest of it to E4. All right, let's do another example. We have neon. Now we were just talking about neon. Neon has 10 electrons, so we're going to need to fill up our orbitals all the way up to 10 electrons. So we're always going to start off with 1s2. That's completely filled. I'm going to put myself a little note, 10 there. 2s2, and then we've got our next one. After 2s is going to be 2p. We're going to do 2p, and we need to get to 10, and luckily enough for us, this p orbital can hold 6. So we are going to write a 6 here, and that is equal to 10 electrons. Now the noble gas notation, you may have noticed when I pulled out my periodic table here, that neon is already a noble gas. So this one's pretty simple for the noble gas notation. All you're going to do is you're going to put a bracket, an E, and a bracket. And that is it for your noble gas. Because this is the same as writing that. Let's do another example. Magnesium. Let's see, where's magnesium? Magnesium is here. It has 12 electrons. So these 12 electrons are going to need to fill up these different orbitals. So we're going to first start by reminding yourself you've got 12 electrons to fill up. And then we'll look here. We're always going to start at 1s. So we're going to go 1s2. There's 2 electrons taken care of. 2s2. There's 4 in total. 2p6. There's 10 total, but we need to get to 12. So if we're looking here, we've just gone to here. The next one is 3s. So then we're going to write 3s, and we just need 2 electrons. Luckily enough, this one can hold 2. So here's our electron configuration for magnesium. Our noble gas notation for magnesium, we're going to grab our periodic table again. We're going to look back. Here's magnesium, it's got 12. And then we're going to go backwards. Neon is our closest noble gas. So we're going to put Ne. And since we learned from our last problem that this is the same as this, all we have to do is bring down 3s2. And there's ours for magnesium. Now these next couple ones, we have phosphorus. Phosphorus on the periodic table has 15 electrons. These 15 electrons, we're going to remind ourselves with a little number below it, 15. And then we're going to start filling up our orbitals. We always start with 1s, so we're going to do 1s2, 2s2, there's 4 of the 15, 2p6, there's 10 of the 14, 3s2, there's 12 of the 15, but we need to keep going. After 3s is going to be 3p. So this next one, 3p. We've currently got 12 and we need to get to 15. So we only need to put 3 electrons there. So there's our electron configuration for that one. The noble gas notation, we're going to go back and look to see which is the closest noble gas. Here's our phosphorus. I got to go backwards. Neon is our closest one. So we're going to do the brackets again, Ne. And we're going to bring down our 3s2 and 3p3 because neon is the same as this portion right here. All right, we'll look at chlorine. Chlorine on our periodic table is right over here. Its number is 17. It has 17 electrons. So I'm going to write myself a little note there. 17. With this one, we're going to start off like we have been. 1s2, 2s2, 2p6, there's 10, 3s2, there's 12, 3p. But now that we have to the 3p, this can hold a total of 6. We're currently at 12. So we need 5 more. We're going to put a 5. There's our electron configuration for chlorine. Now we've got to do our noble gas notation. Noble gas notation, yes, argon is the closest, but it has too many electrons. We got to go backwards. So we go chlorine all the way across my periodic table back to neon. So we've got our brackets, E. We know that neon is the same as these first three, so we're going to bring down 3s2 and 3p5. There's our configuration for that one. All right, so this next one, Ti, that is titanium on my periodic table. That's number 23. So I'm going to write myself a little note. We've got 23 electrons for this one. So we're going to start off like we have been. We start at 1, 1s2, 2s2, 2p6, 3s2, 3p, and since we know we've got 23, we can fill this one completely up. 3p3. Now after that, we have 4s and 3d. That should be all we need. We are currently at 18 electrons. We need to get to 23. So after that, on our chart, we saw that there was a 4s that can hold 2, 19, 20. We're almost there. And then after that was 3d. 3d, and that one is going to need 3. 3d3. All of that added together should be equal to 23. Now for our noble gas notation. When we look at titanium, which is here, we're going to go backwards all the way to, look at that, it's argon. Argon is the lucky winner of this noble gas. Argon. In brackets, argon is the same as from here to here. So we're going to bring down our 4s2 and 3d3. And if you ever want to double check yourself, argon is 18 electrons, so we can always count. 2 plus 2 is 4, 4 plus 4 is 6. Sorry. 4 plus 6 is 10. Woo! I can math. 10 plus 2 is 12. 12 plus 6 is 18. And argon's is 18. We'll do 2 more. Ag is silver. Silver is all the way down here at 47. This one's going to take a little bit. So 47 electrons. We're going to start like we have been. 1s2, I'm going to remind myself here, 47. 2s2, 2p6, 3s2, 3p6, 4s2, 3d, and the d sublevel can hold up to 10. We're going to need to hold up to 10. 10. Then after 3d, we're going to look here. 3d, it goes to 4p. And then back over here to 5s and 4d. So after 3d10, I'm going to bring it down here just because I lost room. 4p. We're going to need to fill that completely up. Then 5s, fill that one up too. Then we're going to need to go to 4d. Now let's count to see how many electrons so that we know how many we need to put in 4d. We've got 4, 10, 12, 18, 19, 20, 30, 36, 37, 38. We currently have 38 and we need to get to 47. And the d orbital can hold up to 10. So all we need is 9 here because we need to get to 47. Yep. Now for a noble gas notation. Silver has 47 electrons. Here is silver. We're going to go backwards to krypton. Krypton's notation ends here at 4p. So all we're going to do is 5s2, 4d9. You can probably see why it's also called a shorthand notation, because this is a lot shorter than this. All right, let's do one more. This is lanthanum. This one has 57 electrons, so I'm going to remind myself by adding a little 57 there. And then we're going to do like we did with the other ones. We're going to start at 1s. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p, 4p6, 5s2, 4d, d can hold up to 10 electrons, 10. Now that we're here, we know that we just did 47. We need about 10 more electrons. So we're right now in the 4d, so let's look at our chart. Here's 4d, so we've got 4d, 5p, 6s, 4f. All right, so this next one is after 4d is 5p. 5p can hold 6. We need about 4 more electrons. And then we've got 6s, which can hold 2. And then we have 4f, which can hold 2. Let's count just to make sure. 10, 12, 18, 20, 30, 36, 37, 38, 48, 54, 55, 56. Oop, we made a mistake. That's not a 2 there. That should be a 1. This is why we always double check. 1. So this is the electron configuration for lanthanum. So let's do the noble gas notation. I'm going to do it above it just because I ran out of room below it. So let's look to see which element is the closest. We have 57. It should be here on the periodic table, so we go back. And that looks like it's going to be xenon. So we're going to do Xe. Xeon, and xeon's notation is everything until 5p. So we're just going to add 6s2 and 4f1. That has been the video over electron configuration and noble gas.